Hi, everyone. This is for day two, no, not day two, day one of ladies and gentlemen, please welcome the quadratic formula. So as you can see here, we're going to be learning about the quadratic formula. This is lesson 5, and we're starting on page 175. So if you want to go and turn to that. Do now was just this warm up right here. And if we right here, we have a bucket of paint falls from the top of a skyscraper that is 564 feet tall. And this is an actual equation that is used by just people in general if they're looking for speed, like CSI, if you're doing stuff like that, right? And so this is like the basic equation for that. So if you're at a building this high, we know that this is 564 feet high. Here's the bucket of paint, like this, and it's gonna fall, right? Boom, like that. So this is the equation for the formula for the height at any given time. In feet per second, so, or in feet, I guess. We're talking about feet per second. This -16 is used for feet per second. If it's the gravity that pulls down, that's why it's negative, because it's pulling pulling the object down, using my words. If it was in meters per second, it would be -9.8, but for us, we're gonna use -16.8, -16. Sorry, not 0.8. So anyway, so here we have the initial velocity, which is the VO. The HO means the initial height, and the T's are just going to be the time, right? And if we notice right here that the initial height is going to be that 564, that's why we plug it into the HO. That's when time is equal to 0. So initial height. And then the initial velocity, a little bit tricky here. Just know that it says falls, which means that nothing is pushing it, nobody's throwing it. There's no initial velocity, it's just falling, right? So it's starting at 0. So in other words, that middle term is not there. So this is what we got. H of t is equal to -16t squared plus 564. All right. And it says use technology to graph the function. We technically don't have to, because we already have all the information that we need in order to graph this. So we know that this is going to be our highest part, right? Because if it's falling, you're not going to, like the paint bucket of paint is not going to go up and then down, right? If somebody were to throw it, then we would have, like, we need to find what that vertex is, but the vertex is at the building. The building is the vertex, right? The paint is not going to get any higher than that. So we know that that's the vertex. If you really wanted to find it, you just use your X. So for the AOS, X equals to negative B over 2A, remember? So X is going to be, well, is equal to negative b. Remember, there is no b. So it's literally -0 over 2 times a, which is -16. And if you already noticed what I noticed, it's a 0. So this is just, it doesn't matter what the denominator is, it's just going to be 0. Okay, which is what we said. AOS right here at 0. That's our vertex. Okay, so it's about almost 600. So that's why I don't have it quite at 600. It's 564. All right. And then we're going to figure out the roots. We know how to do that from the last time. We just set the equation equal to 0, right? Because that's where y is equal to 0 that's the ground, right? So height is 0. And so we're just going to solve for it just like that. So subtract 564 on both sides. And then you just have the -16t squared left. So then you just divide both sides by -16. Why not add 16? Because the -16 and the t are multiplying. So you do the opposite of that, which would be to divide it, okay? So that's what we're dividing by -16. And then you get that to be 35.25. So the only way to get rid of that square is to square root it, okay? And then once we square root it, don't forget the plus or minus, although technically we don't need the minus part because, we can't go back in time. That's irrelevant to us. We just need the positive part, right? So it's just gonna be the positive 5.94. So we know that it's going to be close to 6. That's why I made them close to 6 and -6. That's my roots. Boom, graphed, right? So now, how many seconds will it take for the can of paint to hit the ground? We already know that because that's one of the roots, right? Which root is it? It's probably not going to be the one on the negative side, right? Because that's before we started the time. So it's going to be the one after that. So it's going to be about 5.94 seconds, or we would normally just say, oh, about 6 seconds, because that little point difference, we can just round that. All right, so our learning targets for today is we're going to derive the quadratic formula from the quadratic equation given written in general form, and also connect the quadratic formula to a graphical representation. They are related. Okay, this is not a random formula that some guy just said, oh, let's just do this and this will work all the time to find roots. No, it's not like that. It's very much related to what we've been doing. So we're going to skip over this page. We're going to go to page 5.1. I would not write this down as I'm doing this, or you can always try doing this by yourself. It's actually good for your brain to try and figure this out by yourself after you've seen it before. I'm on page 177. The book already has the answer here for you and already does the work for you. It's good to look at it, but I like to just do it. It's easier for me to explain like as I'm writing it. So let's try this out. So this is how people in general get formulas, right? They go, okay, well, what if we're just gonna, instead of putting numbers here, we're just gonna make it A, B, and C so that we could put any number in there, okay? And so that's how we find formulas. So now, if we're given this quadratic function of A is something, B is something, and C is something, whatever it is, what would the roots be? So we know if we're finding roots, we gotta set the equation equal to 0, right? Because y is equal to 0. We're gonna be like, here, 0 is equal to ax squared plus bx plus c, okay? And so then from there, well, what do we do next? Okay, well, actually, you know what might be helpful is actually if I give you an equation that we can complete the square on, just to refresh your memory. So let's just say, so we'll make this g of x just to say that it's different. And this is gonna be 2x squared minus 4x plus 5. Let's just go 5. We'll try it out, okay? And so here we go. What would we do here first? Well, remember we set this equal to 0. 0 is equal to 2x squared minus 4x plus 5, right? So that's exactly what we did here. Okay, so then what do we do now? Remember we want to just get the 2x squared minus 4x, right? So we got to get rid of this plus 5, right? So we're going to go, oop, mouse, where did you go? Oh, there you are. Don't want that mark. So subtract 5 here, subtract 5 here. Okay, and then we're going to be like, all right, so then I have negative 5 is equal to 2x squared minus 4x. Okay, so far so good. All right, then what did we do here? Remember, oh, actually, do you want to do the same thing on the other side? Okay, so we'll do the same thing on the other side. So we subtracted the 5, right? So remember the 5 corresponds to this plus c, right? So we're going to just subtract out the c, right? Because remember, c is just a number. We're just making it any kind of number. So then what do we have left is negative c is equal to ax squared plus bx, okay? So now, if you notice here on the right-hand side of the numbers, we cannot have this coefficient equal to 2. We need it to be 1, so we're going to factor that out. So we're going to go 2 parentheses x squared minus, remember we're factoring out that 4. So it's like 4 divided by 2, which is going to be 2x. And then we're going to leave some space and put parentheses right there. I'm going to move this over just a bit so you guys can see that better. All right, and then that's going to equal. So remember, we didn't really change anything here. We just factored apart, so we're just going to put that as minus 5. All right, so what is that going to look like over here, right? So we're going to put that minus c here because we're not doing anything with it. We got to factor out this a, right? Because we can't assume that it's 1, right? So we're going to factor out an a, and then that's going to leave us with, so if ax squared divided by a is going to be just x squared, right? Plus, well, how do we get that, this part right here? Remember we divided it, so 4 divided by 2 is 2. So we're just going to go b divided by a, right? So b divided by a. We don't know what that number is, so we just have to say b divided by a. And then x. And we're going to leave some space just like that. Okay? And here we didn't have to write 4 divided by 2 just because we already know what that is. That's just 2. So we simplified it, right? Makes life a little easier. Here we cannot, on the left, we cannot simplify that, so we just leave it as b over a. So now we're going to set up the perfect square. So I'm going to put equals 2 times x something squared, right? So we're going to do the same thing on the left-hand side. So it's going to be a, because that still stays there, x times something squared. Okay, so it looks exactly the same, except this one has a 2, that one has an a. So this is like universal. This one is very specific, just to this equation, only works for that equation. All right, so here we go. So what we're going to do is, remember how we get this number here? We're just going to take that 2x and we're going to split it into half, right? Just if you can imagine in your brain the square, right? That we're trying to make, right? It was a rectangle, now we're trying to make it into a square. It's from a previous lesson, right? And so that's going to be, instead of 2, it's going to be minus 1. We're going to cut that into 2, divide it by 2, right? So same thing with this one right here. We're just going to divide that by 2. So it's just going to be plus b divided by 2a. Okay, that's that number. Okay, it's a weird looking number, but we just can't simplify it. So that's why it looks like that, right? That's why I put the 2 on the bottom. If we put the 2 on the top, that means we're multiplying it. The 2 on the bottom, it means we're dividing it by 2, right? Just like how we divided this one by 2, or the 2 by 2. Okay, so now, how do we get this number over here? Remember, we square up, right? So it's going to be this -1 squared, which is going to be what? +1, right? So we're going to do the same thing here. We're going to just square this guy right here. So I'm just going to do a little bit of work. So it's going to be b times 2a times b times 2a. That's what it means to square it, right? So b times b is b squared. And then 2a times 2a is 4a squared, because we're multiplying them, right? All right, so now we got that part. Okay, do you see the parallels? It's the same. All right, so now, normally I would say, well, we just added 1 to the right-hand side, so what do we do to the left-hand side? We have to add 1 as well, but we didn't really add 1, right? So what we did was we added, let me see, maybe we'll make it green. Remember, it was inside the parentheses and there's a 2. So if we distribute this, that's not actually add 1, that's add 2, right? Because it's 1 times, or 2 times 1, so this is actually 2 times 1, which is equal to 2. So I have to actually add that to that left-hand side. Okay, does that make sense? All right, so again, since I have this factor out here, the a, I have to actually multiply this a with this guy right here, so that it would be, so let me just write it here, so a times b squared over 2a squared. Haha, not 2a squared. I meant 4a squared. Some of you guys were going to be super confused. Like, what? Yeah, 4a squared, right? Because that's what it says. And so remember, this is like over 1. So this a and this a on the bottom, if I have 1a on the top and 2 a's on the bottom, how many cancel out? One of them cancel out. And all I have left, because a over a is just 1, so all I have left is just an a on the bottom. Okay, so I'm going to be like, okay, this cancels 1 out, this cancels out, so that I only have 1a. Then I have altogether, this is, if I multiply straight across, b squared over 1 times a, which is, don't forget the 4, 1 times 4a, which is going to be 4a. I almost made a big boo-boo again. So this is what we're going to add to this other side. So it's going to be plus, and then b squared minus 4a. Okay, so all I'm going to do here now is I'm not going to leave it as 2 plus -5. I'm actually going to like simplify it, right? So make it one number. So it's going to be 2 plus -5, which is -3. Okay, and we're going to do the same thing here. And you're like, but Miss Lee, we can't simplify that. I'm like, well, you can a little bit, right? We can make it one fraction, right? Instead of 2 separate things, right? A fraction and like a number. So we're going to actually put these together. We're going to combine them, simplify it, right? And the only way we could do that with fractions, remember, is if we have common denominators. And if you notice right here, we don't have common denominators. But thankfully, on the bright side, the c has a denominator of 1, right? Which means it's easy. Right, so we're just going to have to multiply the c by 1, right? A funny looking one, but still 1, because if I multiply by 1, I'm not changing the value of c, I'm just changing the way it looks. Okay, so I'm actually going to multiply by 4a over 4a. Okay, because what's 4a divided by 4a? 1. If I multiply 1 times c, it's still c, but in this case, our 1 looks a little bit different, right? Our 1 looks like, so I'm just going to write this over here. It's literally going to be b squared over 4a plus negative, I suppose I could have just written a minus, right? Why be complicated? So minus, because plus negative is the same thing as minus, 4ac. I like to put, you should put your numbers first, instead of like a4c or c4a. So it's going to be 4ac over 4a. Okay, like this. So what we're going to do, since we have common denominators, we're just going to add those together. Subtract them together, whatever, right? So it's going to be b squared minus 4ac over 4a, okay, because it's a common denominator. Now we've simplified it just like how we simplified the 2 plus -5, which is -3. We simplified it on our side too. It looks complicated, doesn't look very simple, but we did it. All right, so then remember the whole point of this was to find the roots, right? So that's what we're going to do. Now we have just x in one place. Now we can solve for x, right? So what is the first thing we need to do? We need to divide by 2, this 2 right here. So I'm going to be like divide by 2, divide by 2. And so we're going to get -3 over 2 is equal to x minus 1 squared. Okay, so we're going to do the same thing over here. We're just going to divide by this a. Let's make that blue. So I'm going to just go, and remember here we don't have any fractions, so I could just divide by 2. Here I have a fraction in here. I don't want to do fraction in a fraction. So what I'm going to do is I'm just going to multiply by, well, I can just go like this, just divide by a. Doesn't even matter. But this one I'm not going to divide by a like that. I'm just going to times it by 1 over a. Okay, or just times an a on the bottom right here if you want to do that. That's the same thing because it's on the bottom of that denominator. Okay, so okay, and if you don't know why dividing by a and timesing by 1 over a is the same thing, just think about this. Okay, so if I go 5 divided by 5, right, which is what we're doing over here, that equals to 1, and this would cancel to be 1, and that's what we want, so that we can get rid of a, so we don't have to keep on seeing a, right? Because 1 times anything is whatever that anything is. And what if I did 5 times 1/5, right? And if you notice right here, this is like over 1, the 5s are going to cancel out and we still get 1. That's how we know that dividing by 5 is the same thing as multiplying by the reciprocal, which would be 1 over 5. Okay, so that's what we're doing here, multiplying by the reciprocal, 1 over a. And if you notice right here, we're going to get, let's try to use same colors here. So b squared minus 4ac over, this is going to be 4a squared, because a times a is a squared. All right, equals, now remember the a's cancel out, happy days, x plus b over 2a squared. All right, so now what do we do from here? Got that square, got to get rid of it, so let's get rid of it. How do we get rid of it? All right, so we're just going to square root both sides there. And so what do we have left? The square root and the square cancel out, so we got x minus 1 is equal to plus or minus, don't forget the plus or minus, square root of -3 over 2. Picked the wrong number. This negatives is bad days, but the process still works. It's still fine. We'll just leave it like that. We're going to talk about these kinds of things, negative of square roots of negatives on Friday, next Friday. Oh dear. In a couple of lessons. How about that? Okay, not earlier than next Friday, but anyways, that's besides the point here. Think of it as a preview. And so what we're going to do here, don't forget the plus minus. So we're just going to say, we're going to simplify this out a bit. So this square root, we're going to square root the top, which we can't. So we're just going to go plus or minus square root. What is that top going to be? Just b squared minus 4ac. But the bottom was the square root of 4. Since it's a monomial, we can totally just simplify this. The square root of 4 is 2. Was the square root of a squared? Just a. Yay. So it doesn't have to be in the square root anymore. Equals to x plus b over 2a. We're almost there. We're so close. The next thing we have to do, the last thing we have to do, right? Add the 1, right? And then we get literally x equals 1 plus or minus the square root of -3 over 2. I am not going to change that. I'm just going to leave it like that for right now because this is not the point, right? But the point was to figure out this process, right? That's what happens when you make up equations on the spot. So we're going to do the same thing here. Remember what is same as this -1? It's like this right here. So we're going to literally, remember the b over 2a? That's a number. That's one number, right? But we just didn't simplify it, right? So it's going to be b over, so subtract b over 2a, subtract b over 2a. And that is, so I'm going to rewrite this so it's x is equal to negative b over 2a plus or minus square root of b squared minus 4ac over 2a. All right. Now, I want you to think about this, okay? Step back, think about it. If you need to rewatch some of that part, rewatch it. You're not going to be tested on it, but it's good to just stretch your brain like that, right? Because your brain needs exercise too. So if you have your highlighters, if you want to, actually not if, you should copy this down right here, the thing on the right or the left, right? How does this look familiar to you guys? What does that look like? Where have you seen that before? You'd be like, I know, Miss Lee. Or maybe you don't know them, and that's okay, but you're like, but it looks familiar. That's our AOS. Remember when we did standard form? We said x equals to negative b over 2a. That's literally the axis of symmetry, right? And once you have, but which makes sense, right? Because remember, once we have the axis of symmetry, where are the roots? They're the same distance away because remember, it's symmetrical. The whole point of axis of symmetry is that it's symmetrical, right? On the left and right side of that axis, right? So that's the axis of symmetry, which means that this guy right here is the distance from the axis, right? That's just the, so let me just write this. This is distance from the axis, from the AOS, okay? And this will always tell you the root. How do you know it tells us the root and not like any old point, right? Because remember at the very beginning, we set that equal to 0, right? And if we set it equal to 0, that means that's when y is equal to 0. That means that has to be the root. There's no choice, okay? So literally this is what we're doing. If I were to draw you a picture, this is what it would look like. So here is, I'm just making stuff up right now. Or making up a problem. So let's say if our AOS is right here. This is our axis of symmetry right here, AOS, right? And so if I said my AOS is equal to, let's say 3. Let's pretend, right? If my AOS was 3, right? Then the distance between from the AOS to the roots, okay, let's say that distance, like this distance, pretend is equal to, let's not make it 2, let's just make it 2, right? So that means we go 2 from the AOS to the right, that's the plus part, 2 to the left, 1, 2, that's the minus part, right? So that's why you have the plus or minus, right? Because what you do it once with the plus and you once with the minus, right? And then those two are going to see those blue dots, those two are going to be your two roots. That's all it means. Plus 2 on the right, plus 2 on the left. Or plus 2 on the right, minus 2 on the left. Okay? That's why we say plus or minus 2. It's within that right there. And so then you would, you know, either do it open up or open down, depending on what that equation was, right? But that's going to be your roots. Okay? Okay. So, oh, and if I were to make something like this, do you see how that works? So that would be where the parabola intersects the x-axis, i.e. roots, i.e. zeros, i.e. x-intercepts. Okay. All right. So that's what that means. But in actuality, you notice that these are common denominators. So we actually just write them all together as one thing. We don't normally memorize it this way. So here we come across the quadratic formula. So I'm going to write the quadratic formula right here. Quadratic formula. So remember that thankfully, right, our denominators are exactly the same, so we don't have to find common denominators because they're already common. So this is going to be x equals negative b. And if you were in class, you heard me sing a song, but I'm not singing that song today. I can't have it on for record. Can't happen. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you know row, row, row your boat. Wait, is it? No, it's not row, row, row your boat. That's a different one. What was it? Oh yeah, Pop Goes the Weasel. Da-dun, da-dun, da-da-da-da-da. Okay, I'm not supposed to sing, sorry. But it's that song. And so x equals negative b. So let's see if you could do it at home and sing the song of Pop Goes the Weasel. And if you don't know how Pop Goes the Weasel goes, look it up and then see if you could find that. If you could say this in the Pop Goes the Weasel song. Most of my students just remember all over to, okay, I'm not supposed to sing, thinking. All right, never mind. Okay, so here we go. That's the quadratic formula. And you're like, oh wait, I didn't get that. Then just rewind. Or you could just go in your book right here on page 178 on the top and highlight the quadratic formula, okay? So here, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, you have to say all over, not divided by, or else it doesn't fit the sum. Okay, and so literally what I do is, this is how I study, right? For math especially. If I have problems, and then if I have problems, I have lots of problems. But if there's a problem that I see that I don't really know how to do, I'm not familiar with, but there's like an example, like a worked out example, I will do those problems. Why? Because then I could see like what their answers is, and they have like work that I can see and go, oh wait, I said that was negative 40 instead of positive 40. Why is it positive 40? And I look back here and go, oh, because it's negative of the negative. So it's, okay, got it. So do you see what I'm saying? That's how you study. Okay, so literally that's what we did in class. So we took this equation right here, or this function right here, f of x is equal to, right? And then we're going to literally solve the roots, find the roots, right? So we figured out first thing, find the ABC, right? It's easy as ABC. All right, and so remember, A, B, and C does not include any x's. If you see x's in there, you did something wrong, like you didn't do it right. Because look at the A, literally the A is the number in front of the, if I go back over here, remember in the very beginning, do you see how A is in front of the x squared? A is not part of the x squared, A is in front of it, right? They're two separate things, right? So A does never includes the x squared part. Those are two completely different things, right? It's like saying, I don't know what that's like saying, but I'm just saying that they're two completely separate things. It's like saying like a brother and a sister, right? One's A and one's x squared. It's saying, oh, who's the sister? Oh, it's the same thing. The brother or the sister is, you know, it's the brother and sister together. It doesn't work like that. It's just one of them. It's just the A, not the x squared part. Okay, a lot of people make that mistake. I've seen that mistake in exit tickets. Don't do that. It's gonna mess you up. All right. So A is going to be the number in front of the x squared, which is the negative 4. B is the negative 40. Please make sure you note. Let me make this in different colors. So B is going to be negative 40. Notice it's that whole, it's including that minus there, okay? So you need to include that. You got to look at in front of it, okay? And then C is just the number, so it's negative 99. Again, look at the number in front, or the plus or minus in front. That's a minus. It makes it a negative, okay? And then let's make our A this purple color. It's just the negative 4. Okay, so now I'm going to put these in colors. If you have not done this yet, you weren't in class, please do it, or try it again. Okay, it doesn't hurt to try it again. Okay, if you already done this in class, but you're like, I'm still a little confused, try it again, right? It will help your brain to learn it better. So remember, x equals negative b. So negative b is just this part. I like to color coordinate because it looks cool. Plus or minus square root b squared. So please, if it's a negative, it needs to be in parentheses. If it's not in parentheses, it's a totally different number, okay? And then plus or minus b squared minus 4. That's always a 4, right? Remember over there, like it was always, it's just a 4, always and forever. And then AC. So A we said was purple, so we're gonna go A is here. Technically A is here. And then C is my yellow color, so yeah, C is here. So notice C doesn't get much love, it only is used once, that's it. But A's and B's get used twice. Okay, so here's my B's, here's my A's, here's my C. And then notice that this is always gonna be a 2, that's always gonna be 4. If you look back at our quadratic formula when we derived it, that had to be a 4 and that was a 2. Like, that's just the way it goes, right? Remember, like we had to divide by 2, and then when we squared it, anyways. So there we go. Right, so here we go. If you notice right here, we're just gonna do that middle part right there. So this is gonna be, you have to put parentheses in there or it's gonna mess you up. So 40, oh, negative 40. Also, if you don't put in the negative, it's gonna mess you up too. Squared, and then minus 4 times, can just push times -4 times -99. You may ask, well, do you need to put those, don't you need to put those in parentheses? No, you don't have to, right? Because I'm not squaring anything. If I were to square something, then yes, I have to put in parentheses. And I get 16. Now notice right here, let me just give this to you right now. So I'm going to just copy paste this, but instead of putting these parentheses, I'm going to take out the parentheses. And if you notice right here, what happens? That answer now is all of a sudden huge. It's like -3,184. Do you see how big of a difference that makes? It's just one parentheses, but look what the difference it made, right? Because remember, this means -40 times -40, which is positive 1,600. This one is 40 times 40, and then you put the negative in front. So 40 times 40 is 1,600, and then the negative, so it's -1,600. It's a big difference, okay? So please make sure you put those parentheses in there. All right, so that's what we got, 16 right there. All right, and then we know the square root of 16 is 4. Yay, happy days. And we're just going to split it up into two parts. So it's going to be 40 plus 4 divided by -8, and then 40 minus 4 divided by -8. Okay, so once with the plus and once with the minus. Remember, that or doesn't mean, oh, pick one, do the plus or do the minus. You pick. It doesn't work like that. Okay, it's do the plus and do the minus because you have two different answers here. Okay, so the way we say it, plus or minus, it's very misleading. We should say maybe plus and minus. I don't know, but it's definitely not an or like a choosing kind of or. Okay. Okay, so, and then once we do that, your answer should be -5.5 and -4.5, and those would be your answers, right? Another practice that we did was this one right here. If you look at this, Paris Pandas baseball team has a new promotional activity. So remember, they're throwing t-shirts, throwing it. Do you like my drawing right here? So they throw it. Nobody caught it, landed on the ground, right? And so what we're going to do is, if you were to imagine like a, let's make a axis here. Oh, that's terrible. Okay, so this is going to be my x-axis right here, right? That's supposed to be straight. This is my y-axis right here, like right on there. So the towel is right on the y-axis, right? And we're going to see what that's going to be, right? This is going to represent time. Okay, at any given time, we can figure out what the height is, right? And so literally what we did was we just set them up. We figured out where our A, B's, and C's were. So if you did not do this one, make sure you do it right now. So go figure out what it is, right? What's my A, what's my B, what's my C? And while you guys do that, I am going to highlight these guys just so that you can see what they are. So they match up in like the shading or the colors. Oh, so notice that I'm including the pluses and the minuses, but I'm not including the T's. Okay? Those don't count as A's and B's and C's. They're not the same. Remember, completely different. Okay? And yet I will still see people on the test putting X's in here for some strange reason. I don't even know, because they didn't listen to this, I guess. And if you feel like you're going to forget, I would definitely use highlighters and help you like visually see that. Okay, highlighters, they help. All right, and then you plug it into the equation. Just check the work here. Notice right here, the negative is not part of the 91. Okay, just like before when we're looking at the -40, right? That was not part of this negative on the outside here. So that's why when we go the negative of -40, that's why we ended up with a +40. Okay, it's the negative of whatever B is. What's the opposite of whatever B is? In this case, if B is negative, then you're going to end up with a positive number. If B, like in this case, is positive, you're going to end up with a negative number. Make sense? Okay, and then again, like I said, please make sure you do that inside of the radical thing. That's going to be, we got 8,633. Once you do that, then you can do -91 plus square root of 8,633 divided by -32. Okay, on what is the thing called? On Desmos, let me try Desmos again. So if we're going to go to Desmos, okay, one more time. So go -91 plus square root. If you go SQRT, it'll also give you the square root. I don't know if you knew that, but you do now. And if I just hit divide here, notice that it's inside the radical, and that's not what I want to divide. I mean, I want to divide, but like I want to divide the whole thing, because notice like over here, I'm dividing the whole entire thing, right? So then, okay, backspace. So what I'm going to do is I'm going to go out of this, right? And if I go out of the square root, like I just push my arrow button and I push divide, still, again, it's not in the square root now, but still it's not including that negative 91, right? So what do? Best thing to do is just put, if you close the parentheses, Desmos will automatically like put the parentheses around the whole thing. So you don't have to go all the way to the beginning. You can if you want to, but you don't have to. Now when I push divide, now it goes over the whole entire thing, right? You see how that makes a difference? Okay, so then I'm gonna go negative 32. Okay, and then we're gonna get this number right here. So negative 0.06, we're gonna round it to the nearest hundredths place. That's where we got negative 0.06. And then the cool thing is you can just go copy, paste, and the only thing we're gonna change now is change that plus to a minus, just one little change, and guess how big of a difference that makes, right? Now it's gonna be 5.75. Remember that 4 is closer to the 5 because that the one right next to it is 7. So this would actually round up to 5.75. Now, the question here for number 2 is to determine how long it will take for a t-shirt to land back on the ground after being launched, right? And if you notice that, we're not going to take the negative one, because negative, before we even started the time, it was already on the ground. We're not talking about that, right? But yeah, it is going to be the 5.75. Normally for these kind of questions, we use the positive one. If you have 2 positive ones, then you're going to have to start thinking about which one we're talking about. But normally one is negative and one is positive. And we're always going to use the positive one. All right, and classify your solutions as rational or irrational. Remember, rational, and SBA loves like, oh, what's rational? What's irrational? Right? Rational means I like to think of, ooh, definitely not that. I like to think of like fractional, because it can be written as a fraction. So I know fractional, well, I guess fractional is a word, but rational, fractional, it's kind of in there, right? Kind of rhymes. So it can be written as a fraction. And my one hint to you, if it's not a perfect square, 99.99% of the time, it's irrational. It cannot be written as a fraction. It's a number that keeps on going, has no pattern, and doesn't stop. I guess that's what keeps on going is, right? So yeah, so in here, if we have the square root of 8,633, we know that it's not a perfect square. Well, I'm gonna just check one more time, just in case. 8,633, right? If you notice right here, do you see that? Do you see what I see? So do you see there's no apparent patterns that we're seeing? It's not repeating or anything like that. That's what we're gonna call irrational, okay? So this is definitely gonna be, so this is cannot be written as a fraction. That's my short way of doing that, okay? So this is definitely going to be irrational, because we got a square root in it. But you're like, but Miss Lee, it's a fraction. I'm like, yeah, but you have that square root in there. That doesn't count, right? You can't just go like, oh, pi over 2, written as a fraction. No, that doesn't work that way, because pi is irrational. If you take an irrational number divided by 2, it's still going to be irrational, right? Have you tried to talk to somebody who's irrational? Actually, you just tell them to go to bed. Don't tell them anything. They're irrational. I'm just kidding. All right, so let's see here. We've already talked about this in our previous one, right? Remember, this is exactly what we were talking about. That's first part right here. It's talking about the AOS. The second part right here is talking about the distance from the AOS, right? That's going to give us the roots, right? And so for them, what they did was, in the book, they're just literally like, this is one of the roots. Here's the other root. So one of them is plus, the other one is minus. Those are the 2 roots, yes. And you could totally write it like that. And you can, I'm not gonna like dock you for it. Just make sure that, or you can totally write it like the plus or minus. Where did my, yeah, oh yes, this one right here. So if you can leave it like this, 1 plus or minus the square root of -3/2. We'll talk about that later with that negative thing. But if you cannot reduce this anymore, then you just leave it like that, right? But if you can reduce it, like how we did here, like we knew what the square root of 16 was, it was 4, and we can 40 plus 4, we can add those together, then you have to simplify as far as you can, right? But if you have a square root that's not, it's not a perfect square, then you could leave the answer with a plus or minus whatever the square root of 5 or square root of whatever the answer was for the radical. All right. Let's see here. Go down a little bit more. This is literally saying what I had said before. If we have our AOS right here, right? They had found the AOS to be this 1/4, x equals to 1/4, right? So that's our AOS right here. AOS right here. It's the same thing. And the only thing they did was they found this part right here, and they found it to be negative 11/4. So that would be that distance right here. And then also this distance right here, plus or minus both ways, right? And so then we get the roots. Oh, that's terrible. So then for them, they get the roots right here. They're saying, oh, these are the roots, the actual roots. They're going to take that 1/4, add it with the negative 11/4, and 1/4, add it with the positive 11/4, and then they would get these numbers like that. Again, if I were you, I would go and practice that. If you don't really like the parentheses or the fractions in there, then try some other problem that doesn't have that, right? Okay, so your homework then, remember it's 202, review numbers 1 through 3. Okay, it's just right here. This is all review of stuff that we've done before. Complete the square, right? Complete the square, we've done that. So if you don't remember how to do that, you can do what we're doing earlier, right? Because we were just doing that for one of those problems in the very beginning, okay? When we're doing the quadratic formula.